In this video, we present Incremental Task Modification via Corrective Demonstrations, or ITMCD, a novel method that utilizes corrective demonstrations to inform incremental changes to a task model. We envision a scenario where robots are deployed with a set of pre-programmed models for common tasks. After deployment, the robots may encounter new conditions or use cases not encoded in the models. Rather than learning a new model for those cases, which would require many demonstrations, it would be useful to enable end users to correct baseline models by providing a few demonstrations in the target environment. The key idea is to allow robots to reuse portions of the model that still apply and learn new components as necessary. To accomplish this, we propose an algorithm that modifies a baseline task model represented as a finite state automaton through iterative constraint search and selection. The FSA model is converted to a STARHMM representation in order to perform subsequent model learning and selection steps. A set of candidate corrections are proposed that allow a specified combination of structural changes, offering different modifications to the model. These could include modifications of existing primitives or the addition of new primitives and/or transitions between primitives. This is accomplished by constraining the parameters of the STARHMM during the edit application process. Given these constraints, expectation maximization is used to maximize the likelihood of the new demonstrations under the STARHMMs associated with each candidate correction, resulting in a set of alternative models. Approximate Bayesian model selection then chooses the best model update to incorporate back into the original model, balancing increased likelihood with model complexity. We evaluate our approach on a real-world pouring task. An initial model is constructed from demonstrations of pouring from an open pitcher into a mug. If the task changes to pouring from a closed pitcher, executing the policy in the learned model would result in spilling the contents of the pitcher. By providing corrective demonstrations that include the removal of the lid to ITMCD and running the update procedure, we find that under certain conditions, our approach can successfully learn new primitives for the unmodeled behavior of lid removal and correctly attaches them to the existing task model. These successful task modifications occur when the modeled segments of the corrective demonstrations closely follow the current task model. ITMCD accomplishes the model updates automatically without specification of whether new primitives should be added or how new primitives should be attached.